Hi, in this video lecture we are going to learn about Karnaugh map methods, kmap techniques. So we are going to solve problems based upon kmap. On completion of this video lecture, the learners can be able to solve problems based upon kmap. Kmap in the sense number of variables will vary, 2 variable, 3 variable, 4 variable, up to 5 variable kmap simplification we can able to learn. So this is a method which is for minimizing the minterms or maxterms present in a Boolean expression. So kmap is a method to minimize the number of minterms or maxterms present in Boolean expression so that the number of ICs used can be reduced. So it reduces the circuit complexity of the given digital logic circuit. So main important method to minimize the given circuit is called as kmap method, and it's very simple and easiest method. So there are kmaps, so problem solved based upon 2 variable kmap, 3 variable kmap, 4 variable kmap and 5 variable kmap. Number of variable increases, then kmap method also increases. So we can solve it by up to 5 variable kmaps. So for 2 variable kmaps, let the 2 variables are a and b. So a and b, the number is should be binary, should be considered as a and a bar. For b, it should be considered as b and b bar. The minterms can be written as m0, m1, m2, m3. The cell combinations for 2 variable kmap, the number of cells are 2 power 2 is equal to 4 cells should be there. So m0, m1 and m2 and m3 positions should be vary like this given in this column. Similarly for 3 variable, 2 power 3, 3 means n value is equal to 3. So 2 power n cells should be there. So 2 power n means 3. So 2 power 3 equal to 8 number of cells should be there. For 4 variable, n is equal to 4. To 2 power 4 is equal to 16 cells should be there. For 5 variable, 2 power 5. So n here 5. 2 power 5 equal to 32 cells should be there. So 3 variable kmap, the cells should be like this 0, 0, 0, 1, 1, 1 and 1, 0. Here we are considering the variables like this, a in this right side and b and c as a as the left side and b and c as the right side of this gray line. So here we are writing bc as 0, 0, 0, 1, 1, 1, 1, 0 as gray code sequence. So here 0, 0, 0 is the m0 term, 0, 0, 1 is the m1 term. That is simply we have to write the horizontal and vertical combinations here. Then for 4 variable combination, as said earlier, it should consider number of cells as 16. This number of cells should be like this. So grouping of kmaps. So grouping is very important. The adjacent number of ones can be grouped. That is called as pair. If adjacent number of 4 ones are grouped, then it is called as square. So here this is 2 adjacent number of ones. So this is also 2 adjacent number of ones. So this can be grouped. And then next is the 4 adjacent 4 adjacent ones. So this is also 2 adjacent ones. So here we can tell when folding this means these 2 ones will touch, so that we can tell this is adjacent ones. Then so here minimization, here 2 adjacent ones groups are there overlapping. So this is the way to represent, and here this also adjacent ones. These are the methods, these are the ways we are considering the adjacent ones. Here this 2 ones are there, and top and bottom another adjacent ones. 4 variable ones are called quads. Quad should be like this. So 4 adjacent ones should be, this is one quad, and similarly we are having another one quad like this. So next is, this is also one quad. So grouping 4 adjacent ones like this. This is also grouping 4 adjacent ones. This is also 4. These are the different ways. This corner ones are considered as adjacent ones. So these are the 4 different types of adjacent ones. Grouping 8 adjacent ones is called as octet. So octet is the way to consider 8 number of adjacent ones. Here these are 8 adjacent ones, 8 adjacent ones, and this is also 8 adjacent ones are grouped here. So this is called as octet. Kmap minimization. So for kmap minimization, so all the 4 columns are considered, means we have to we can leave that side variable ab, and ab we have marked 0, 0, 0, 1, 1, 1, 1, 0, and horizontal also 0, 0, 0, 1, 1, 1, 1, 0. So all are there means we can leave. So in the top, in CD column 0, 0, 0, 1 are there. So you can leave the varying literal. Literal means A, B, C, D are the literals. You can leave the, we can leave the varying literal. Here first literal is 0, 0 and for the second one 0, 1. So both 0 is common. Varying one is second literal is varying. So we can leave the second literal. So same one means the first one 0. 0 is related with C. And 0 means that is C bar. 1 means that is C. So this answer of this is Z bar. Similarly this one also the vertical side can be neglected, and horizontal side we are having two columns 0, 0, 0, 1. Varying column is 0, 1s are varying, 0 is same. So here the answer is A bar. Similarly here these are considered as octets. Here we can leave the horizontal columns. In the vertical column top 0, 0 and the bottom 0, 0, 0, 1, 1, 1 and 1, 0. 1, 0, the same column is 0. Okay, so similar in this way we can write. So simplification of product of terms. This product is POS terms can be simplified by using this kmap method, by using quads, octets, pairs. Like this we can. So if terms are given means you mark the terms, combine the adjacent ones, and as said earlier you minimize it and write the expression. Similarly for this problem also write the given expression, and here we can find one quad and another one is there that can be combined with a pair, so it can be grouped. That is called as minimized expression of this one. This is for 4 variable kmap. Same procedure is followed. We can simplify the given expression and writing and finding the SOP terms and marking it into kmap, then grouping the adjacent ones. We can find here one quad and one pair. So and one single one is there. Single one cannot be combined with any other one, so it can be written with the full values. So similarly another one problem is here. In this problem we are writing all the minterms and inside the kmap cells. After writing we are finding the adjacent ones and grouping the adjacent ones according to the priority given as octet, then pair, octet, then quad, then pair. Then combining all the values we can get the finalized expression. Similarly next in this problem given SOP terms, we are writing the SOP terms inside the kmap cells and grouping this we can writing the final expression according to the grouped terms. So next problem also same thing, writing this SOP terms inside the kmap cells A, B, C, D. So 4 variable kmap, so 16 cells are there. Writing this all the given SOP terms in the 16 cells and grouping all the minterms according to octet, quad and pairs priority, and combining we can write the finalized expression. So on completion of this we can solve the problems based upon 2 variable, 3 variable, 4 variable and 5 variable kmaps. So kmaps are used to minimize the circuit complexity. So number of ICs are number of gates used are less, means this IC recommend in this IC also the functioning will also speed if number of gates are less. So that's all about kmap minimization.